G'day. Copy the heading down and then we'll do some hard yakka. We will start by testing your knowledge, so put down the numbers 1 to 10 under your heading. Question 1. What metal causes the red colour in these rocks and in our blood? Question 2. The oxide of what metal mined on Groote Eylandt is found in torch batteries? Question 3. What metal used to make paint and sunscreen is found in the black mineral sand rutile? Question 4. What metal used to make steel stainless is found in luxury car bumper bars? Question 5. What black non-metal is found in coal and the blast furnace fuel, coke? Question 6. What grey metal is used to galvanise iron and to protect it from corrosion? Question 7. What group 2 metal is found in limestone? Question 8. What block of metals have variable valence and coloured compounds? The S block, P block, D block or F block? Question 9. What heaviest naturally occurring element is found in this ore, which is called yellowcake? Question 10. What metal is found in chlorophyll in plant leaves? Put aside heading Cobalt. In West Australia, cobalt occurs as a cobalt arsenic sulfide mineral called cobaltite. It looks a little bit like pyrite, which we call fool's gold. Cobaltite is found together with nickel sulfide in some black igneous rocks called peridotites. Swedish chemist Georg Brandt was the first to extract cobalt from this ore in 1735. The metalworkers in the ancient smelters thought that both metals, cobalt and nickel, were quite evil. In the case of cobalt, the arsenic fumes released during smelting tended to kill them. The workers called the ore kobold, meaning goblin or little evil green person. The name cobalt soon followed. Arsenic is a slow but dangerous poison. Copper's logs are in common use in Australia and contain arsenic. If you burn them in wood fires, or worse still in barbecues, the arsenic goblin will poison you. Cobalt metal is very hard and has a high melting point. It is often used in high-speed steel drills. Iron, cobalt and nickel are the three great magnetic metals. School magnets are often made of a lightweight alloy called alnico. The name tells you the metals in the alloy. But it is the compounds of cobalt that are of the most interest. Cobalt-2 aluminate has been used for thousands of years as a distinctive blue colouring in paints, glasses and glazes. It is poisonous and should not be handled or the plates eaten off. You may be familiar with cobalt chloride paper, which is often used to test for humidity. When there is water around, it forms a hydrated form with 6 waters and is pink. When dry, the water leaves the chemical and it turns blue. There are a lot of good pracs involving these chemicals. Another use for cobalt compounds is in the new lithium-ion batteries found in laptop computers and cameras. One of the battery electrodes contains lithium cobalt oxide. The electron transfer, which moves the electricity, is caused by the cobalt changing its valence. The process is reversible, so these batteries can be recharged using the mains power. Copy down the next side heading, Element 28, Nickel. This graphic shows the belts of asteroids in our solar system. Our planet is believed to have been formed by the accumulation of asteroid rubble. As the rubble grew, our planet melted and formed layers. Sometimes rogue asteroids fall out of orbit and hit the Earth. This 15-ton meteorite monster was found in Oregon, USA. It contains 91% iron and 8% nickel. The theory is that this material is similar to what is found in the Earth's core. Big nickel sulfide deposits are found at Sudbury in Canada and Norilsk in northern Siberia. The Canadian deposit is most interesting. There are two old impact structures here. The one on the right is 34 million years old and has formed a lake. The older, much fainter one looks like a football on the left and is 1.8 billion years old and 250 kilometres across. This is where the nickel is, and the original nickel source may have come from a big asteroid. The Russian deposit is much younger and formed when deep volcanoes brought up dark nickel-containing rocks from the mantle. The history of the cold, heavily polluted city of Norilsk demonstrates the horrible suffering experienced by many Russian people. The satellite photo today shows the dead tundra areas in pink around the mines. Australia's smaller and safer nickel mines occur near Kambalda in West Australia. The nickel they produced is used in aeroplane turbines, magnets, and in all our modern coins. Its compounds are green or blue. Write down the next heading, copper. Copper has a 9,000-year history of use by people for very good reasons. It is an unreactive metal and is sometimes found in element form in nature. The ancients found that they could heat the native copper and pound it into useful shapes. A lot of its compounds are very pretty and attracted people to use them for jewellery and to experiment with them in furnaces and to extract the metal from the ores. By 5,000 years ago, they alloyed copper with tin and started the Bronze Age. One early source of copper was the island of Cyprus in the Mediterranean west of Israel. The Roman rulers of the time called the metal cuprum, meaning metal of Cyprus. That is why the symbol for copper is Cu and not Co, which is the symbol for cobalt. Copper has been mined for hundreds of years in many parts of the world. The main ore is a form of fool's gold called chalcopyrite. It is copper iron sulfide. Most pits also contain some of the more colourful secondary copper minerals. We think chalcopyrite formed as gas leaked from underground magmas on the seafloor. The smelly chimneys produced are called smokers. Australia has an extensive range of copper ore bodies which have enriched our nation greatly, and some have been mined for over 100 years. The modern mines are in hot, isolated desert areas. The toil of our tough, innovative miners and engineers continues to prop up our faltering economy. Pollution can be a problem with sulfides. Air and water react with the ore, forming sulfuric acid. This modern plant has holding ponds and waste treatment. The high rainfall mountainous areas of Bougainville and New Guinea can wash all waste downstream and kill sections of the river. In the case of the Bougainville mine, a military rebellion followed. The smelting of sulfide ores produces sulfur dioxide gas that has to be removed and processed into useful products such as sulfuric acid. A modern design smelter will emit mostly steam. Australia's coals are still exported because they have less sulphur than the Northern Hemisphere ones. Independent environmental monitoring by properly equipped scientists is essential to safeguard our rivers, aquifers, soils and the atmosphere. Australia needs to emerge from its isolation and help solve the many problems of our nearest neighbours. In spite of these drawbacks, copper remains one of the Almighty's better metals. In fact, the average Aussie home has about 90 kilograms of the stuff. Safe copper pipes have replaced poisonous lead and rusty iron ones. It is used in air conditioner coils. It has a low resistance to electricity and is found in most electric wires. Alloyed with zinc, it forms brass for things like taps and is even good for the arthritis. Copper sulfate kills algae and fungi in fish ponds, and copper oxychloride prevents grapes from getting a fungal infection. Copper metal resists most acids, except for powerful nitric acid, which is dissolving it here. Your next heading is zinc. In far west New South Wales lies the town of Broken Hill, which is the site of one of the world's largest silver, lead and zinc ore bodies. It has been mined by a number of companies since its discovery in 1883 by a boundary rider called Charles Raspe. It has always been a tough place to live and work, with the heat, dust storms, dry country and lead in the soil. This drilling rig, being visited by my students in 1972, is testing the ore at depth. The zinc ore, which is part of the ore body, is called sphalerite or zinc sulphide. We separate it from the rock by froth flotation and remove its sulphur in a distant smelter. Zinc is a grey, moderately reactive metal with valence 2. It forms one electrode as the outside case of common torch batteries. But its main use lies in its ability to protect iron from corrosion. Iron is dipped in a bath of molten zinc in a process called hot dip galvanizing. The zinc then rusts to a white powder before the iron rusts to a brown powder. Another coating material is zinc alum. White zinc oxide is found in sunburn cream. It has some other medical uses as well. If you do not immunise yourself, you can catch the nasty chickenpox virus and have to use calamine lotion. This is zinc oxide plus a little iron oxide to colour it. Copy heading number 5, silver. Silver has been used by people for thousands of years. Like most ancient metals, there are problems with the symbol. Whereas the name silver is derived from older Anglo-Saxon and Germanic words, the Greeks and Romans used argentum and argyrus, derived from the older word arg, meaning white or shiny. It certainly shines beautifully when polished. This 160-year-old spoon was made by my great-grandfather. Silver is a very unreactive metal and is occasionally found in nature as silver nuggets, but its main ore is silver sulphide or argentite. At Broken Hill, it occurs with lead and zinc. The ancients discovered that food on silver plates stayed fresher longer. It does have antibacterial, antiviral and antifungal properties. It may be that as silver reacts with sulphur gases in the air, silver ions are formed which are quite reactive and kill the little bugs. Silver chemicals are not a medicine and will turn you a different colour if you absorb them internally, as this man found. Silver is a wonderful non-toxic metal and has many uses. It is a pity that it is so rare and valuable. It has been used for food implements, coins and medals for hundreds of years. Australia's silver coins used to be silver, but changed to nickel and copper with the advent of decimal currency in 1966. Silver metal is the best conductor of heat and electricity. It is too expensive for use in normal wiring, but is used for quality electrical coatings, fuse wires and switches in electrical appliances. Silver found early uses as the reflector in mirrors because it was the shiniest of metals. Cheaper aluminium is a modern substitute. When a metal is unreactive, its compounds can be quite reactive, so you don't handle compounds such as silver nitrate or your hands will be stone black. Most silver salts are photosensitive and are kept in dark bottles to stop them from darkening in sunlight. This property attracted the attention of a Frenchman who experimented with film containing silver nitrate. This is the first ever photo taken in 1813. We are deeply indebted to Joseph Nicephore Niepce. Various characters jumped onto the photographic bandwagon. This is Roger in 1855. This picture is dated 1867. Pictures like this one helped to cure half the Australian population who had been exposed to tuberculosis. The eradication campaign reached its peak in the 1950s. This very distant photo was taken in the 1960s. Silver oxide is used in button cells in small electrical appliances instead of cheaper mercuric oxide, which should be banned. Silver compounds were used on wounds and burns in World War I to treat infection. Bacterial infections are making a comeback as we become careless about infectious disease and hygiene, and antibiotics lose their effectiveness. Your next heading is Mercury Hg. You will recall that the modern periodic table can be divided into 4 blocks of elements. On the left are the 2 columns that make up the S block. On the far right are 6 columns making up the P block. In the middle is the D block elements shown in pale red. And at the bottom are the 2 rows of F block elements. This video has been looking at D block transition metal elements. When we zoom in on the D block, we find that mercury at element 80 is the heaviest of the naturally occurring transition metals after the non-poisonous metals, platinum and gold. In fact, there are only 3 heavy elements after mercury that are not radioactive. They are the poisonous metals thallium Tl and lead Pb, then the non-toxic, slightly radioactive semi-metal bismuth. Then comes Madame Curie's polonium element 84, and that and all the elements after it are dangerously radioactive. The chemicals of life tend to be lighter metals such as sodium, calcium and magnesium. Heavy metals are often quite poisonous to humans and become biological time bombs if we use them too much and dump them into the environment. For example, the toxic heavy metal thallium was used in a medication for pregnant women for a short period of time. The result was a wave of births of children with deformed arms and legs. We called them the thalidomide babies. Mercury is probably the most toxic of the heavy metals. The ancients were particularly attracted to the liquid metal that they called quicksilver because it moved quickly away. Another name was hydrargyrum, which in Greco-Roman meant liquid silver. Its ore cinnabar was pretty and used in eyeshadow. The alchemists thought that mercury might be a key ingredient for making gold. The mercury drove them even more crazy than they were before. As the modern scientific revolution swept through Europe, mercury metal unfortunately found abundant uses. The mercury thermometer was invented around 1700 by the German Fahrenheit and is only now being replaced by digital and alcohol substitutes. The mercury barometer for measuring air pressure was developed earlier by Evangelista Torricelli. It has been replaced by the aneroid barometer. A related mercury machine called the sphygmomanometer was used to take blood pressure in hospitals until fairly recently. Mercury switches found ready uses in devices such as doorbells, and buckets of the stuff were used to provide efficient electrical contacts in power station generators. Tooth decay has long been a scourge of humanity. Most people suffered from painful rotting teeth that caused them blood poisoning as well as shocking bad breath. The tens of thousands of dead soldiers lying on the battlefield of Waterloo were seen as a valuable dental resource. Healthy teeth were removed and sold to denture makers. The bodies were piled into mass graves and the bones later dug up and ground into fertiliser. Mercury dissolves other metals to form a soft silver amalgam. For 150 years, dentists have drilled out decaying teeth and worked an amalgam of silver and mercury into the gap. The filling lasts for about 15 years, and both metals are poisonous to tooth decay germs. People like myself did not drink fluoridated water while young. My teeth decayed as in times of old, and are now mostly mercury and plastic. So keep drinking fluoridated water, brush your teeth and gums regularly, and use dental floss. The case for the banning of mercury has been building for over 200 years. It began when hat makers in Britain and America started to go mental. Mercury vapour and mercury compounds attack the brain, destroying it bit by bit. This Canadian microscope diagram shows how very small concentrations of mercury shrivel nerve cells in animals. The old hat makers washed felt in mercury nitrate. They dribbled and acted like drunks and finally could not talk and often died. The expression mad as a hatter became common. You might like to research the Minamata disaster that began in a bay in Japan in 1956. A chemical plant was leaking methyl mercury into the bay. Shellfish absorbed the poison and it concentrated in the fish that ate them, and even more in the humans that ate the fish. Over 1,700 people died, with the children being the worst affected. There are over 10,000 victims. But let us move closer to home. Australia is the dry continent. Our rivers and streams are lazy and do not flush out rivers and bays of pollution as water does in many countries. It is probable that our bodies can cope with small amounts of mercury in the safer forms. These include the metal itself and the insoluble compounds such as mercury sulfide. Mercury vapour in light tubes is very toxic, and 80% when breathed in will enter the blood and head for the brain. The organic compounds methyl and ethyl mercury are extremely toxic and concentrate in fish and humans. We should beware of concentrating mercury in the environment. Old gold mines and illegal mines in some countries use mercury to attract the gold. These sites are toxic. Chlorine plants and paper bleaching plants use tons of mercury in their mercury cells until a new process called membrane cells was introduced in 1970. Botany Bay is polluted, and eating too much fish is a hazard. The old plants overseas continue to operate, and their product competes with cleaner plants in Australia. We should ban those imports, otherwise our imported seafood will be contaminated. Of particular concern are ultraviolet lamps, fluorescent lamps, green compact fluorescent lamps, televisions and computer monitors. They all rely on mercury vapour to function. Indeed, they are a witch's mixture of toxic heavy metals. A typical television monitor can contain 4 kilograms of lead as well as barium and mercury. Little recycling of these materials is happening in the lucky country. Most of these products are compacted in the local garbage truck. Properly organised recycling is vital, and better technology needs to be encouraged. Some progress is being made. A number of products are replacing mercury in teeth. The old antiseptic mercurochrome is rarely used. In the meantime, we better not drive these things insane. Cheerio.